All right, so it's nearing Christmas time. We're gonna go ahead and build a little string of Christmas lights. Now, I've got a bit of an idea for this, and this just kind of came to me, so I decided we're gonna build it. So this will run off of USB. I've got a USB lead already set up here. I've got a section of this twisted wire here. Basically the way that I did this is it's 26 gauge magnet wire, stuck one end in the end of a drill, and then stuck or just held onto the other end with a pair of pliers and twisted it up that way, so it makes a nice sort of twisted pair here. So, and it's even red, so that works with Christmas. It'd be even better if you had like red and green wires and twisted those together. Actually, it'd be a lot better because then you could tell what polarity what polarity you had. So my plan with this is to control the LEDs in pairs. So blue and green will be a pair, and red and yellow will be a pair. And the reason why I'm doing those two as pairs is the red and yellow, I'm thinking, have a lower forward voltage than the blue and the green. So these should have a forward voltage of about 3. These will have a forward voltage of about 2. And essentially what we're going to do, let me see, I gotta find some paper. And another part that I don't have shown here is a little piece of perf board, but I'll get to that eventually. So basically what I'm going to do is we'll have our chip over here. Let's just say we have 2 pins coming off of it. And I've done the math on this. The little ATtiny 85s can put out 40 milliamps per pin. But anyway, what we're going to do is we're going to have 2 output pins on this chip. And then these will go along the 2 wires. And we're going to take our LEDs and we're going to put one this way. And then we're going to put one that way. And then we're going to just alternate this. So I'll do a section here. I plan on doing this so it's like maybe like 6 LEDs long, or 16 I mean. But I'll just show you what a section is going to look like. What some of it will be anyway. Not great at drawing this stuff. And actually in this area we're going to have one of the 39 ohm resistors, and then I'm going to have another one over here. So it will end up being, so this will be blue, red, green, yellow. And then what we're going to do essentially is, since these are since your microcontroller is capable of driving the pins both high and low, what we can do is we can make this one high and we can make this one low. And when we do that, we're going to turn on the blue and the green, and the red and the yellow will be off. And then we can flip this around, so this one's positive and then this one is negative. And then you'll end up having current flow through here and here. So you have the red and the yellow on and the blue and the green off. And if you do that fast enough, you can actually make it look like all 4 are on as well. Or if you do it slowly, you can have different, alternating patterns of having sort of separate controlled LEDs. So anyway, that's how we're going to set this up. Haven't actually tested it yet. Now I think I'm going to do 4 yellows, 4 greens, 4 reds, and 4 blues, which will make for 8 LEDs on each of these strings. So there'll be 8 LEDs on one string, and well, let's see if I can explain this a little bit better. There'll be 8 LEDs that are going this direction, there'll be 8 LEDs that are going this direction. And with 40 milliamps a piece, or 40 milliamps-ish worth of current in total, we should be around 5 milliamps per LED. It won't be quite that much because the resistor values are a little bit higher than that, but that should actually work fairly well. Now I'm thinking I'm going to need to be about 2 1/4 inches apart on the LEDs, which is pretty reasonable. This is a 36-inch piece of wire, so it'll work out to about 2 1/4 inches, I believe, which is right here on my tape measure. So they'll be reasonably far apart. And the trick with that is going to be actually getting the wire up. What I'm kind of hoping to be able to do here is going down this wire, finding where that 2.25 mark is, I need to straighten this out a little bit better. Kind of hard to do though. But what I think I can do anyway is go down to 2.25 inches, stick a pair of tweezers into the or some other sharp object. Maybe I can pull them apart with the tweezers, and then just kind of splay those out and get the LEDs into that sort of area there. So I think that'll work. And then I'll just take the soldering iron and melt the coating off, and it should work just fine. I'm just gonna go right down this wire doing that to it until I have 16 spots plus the end one. So that should work out just fine. All right, so I'm gonna go ahead and continue recording it like this. I've got a lot of junk on the table, so I apologize for that. But anyhow, yeah, there's too much stuff here. I've kind of got the mic just kind of stuck on the tripod there. It's kind of far away from me. I'm not sure how well it's going to work, but we'll keep on going here. But I'm just going to go ahead and speed this part of the video up probably because there's not a whole heck of a lot to see. So I'll get to it. Alright, so it's not perfect by any means, but they'll be good enough for what we want to do with them. It should work out just fine. The next step will be to get the insulation stripped off of it, which is where things start to smell really bad because we're just going to burn it right off the soldering iron. So I'm going to bring this in here and just kind of situate this in here somehow. And I'm going to set up a fan here. This is a kind of a project that's still underway right now. Just a little fume blower thing here, 3D printed. Not done with it yet, but it's got a start to it at least. Go ahead and kick that on and I'll get to soldering. Alright, so that ends that. All the wires are stripped there. Definitely doesn't make your room smell good, but it's effective and it's reasonably easy and it doesn't break the wires. So next step is going to be probably one of the more painful ones, and that's going to be actually getting the LEDs on here and getting them all to be the right polarity. So the first thing I'm going to do is set up the continuity meter. So we're going to set this to continuity mode, and I'm going to take one lead and just grab an alligator clip wire, and I'm going to hook it to the bottom of one of these, and we're going to call that one ground. Doesn't really matter, but we're going to call it ground. And then what I'll be able to do is take this other lead and be able to tell which one is the quote-unquote ground here. This will essentially be driven with AC, so the first one's there, and I'm going to solder the first LED so that the negative pin is actually on that quote-unquote ground. So we'll start with blue. And I think what I'm actually going to do with these is go ahead and just tin them and then maybe put a bit of flux on everything and just stick it together. But I'll just go down the line and I'll wire it exactly as I did in that sort of schematic that I showed, and we'll see if it actually works. Alright, so it appears as though my camera is still recording at least, and I'm going to go ahead and give this a bit of a test using a coin cell, and you'll kind of get an idea as to how this works. So if I put the positive on this side just to start with, and actually I'll unravel a couple of these just so I can get on there a little easier. So we'll go like that, and you'll see right now we have yellow off, red off, yellow off, red off, all the way down the line. So you can see that, and then if I take the battery and I flip it over and we hook it up, we have off, green, off, blue, and that goes all the way down the line. So it looks like I got them all wired in here right, so I can go ahead and cut those excess legs off. And you can kind of imagine if we were to flip the battery back and forth extremely quickly, we can get it to the point where your eyes think that they're both on at the same time. So we go ahead and cut these down, and then we're going to work on the actual microcontroller part of it. And I might just dead bug the microcontroller. I'm not entirely sure that we need the piece of perf board. But actually I might put it on there anyway, because then it's easier to pull this out and reprogram it if I choose to do so. Alright, so that pretty much finishes off the circuit. I'll have to get some hot glue and insulate all the LEDs and stuff still, but that's the back of it. If you can see that there, maybe I have to use the LCD on the camera there. Pretty simple circuit, as you already probably know from the schematic that I showed earlier, but we just got the socket there. 2 resistors, no real particular reason to use 2, just because that's what I found laying around first, so we were just shooting for somewhere around 70 ohms, and these are 39 apiece, so we've got roughly, 78 ohms there. So that should work just fine. They're hooked up on what are considered by Arduino to be pins 0 and 1. They're both PWM pins, and I'll kind of explain what I'm going to do with that in a little bit. But for now, I'm going to go ahead and get some hot glue on this, and then I'm going to start writing code for it. Alright, so as my glue gun heats up, I'm going to go ahead and just give a little test without the actual chip, just to make sure that everything's hooked up right. Nothing will explode if I start hooking things up, so this should work just fine. So right now I've got red and yellow. Yellow is not amazingly bright, actually. Well, neither color is amazingly bright. I'm not really pushing all that much current through them, so I guess it's to be expected, but it's good enough for a visual effect. Blue and green are pretty bright, so that's interesting. I would have expected red and yellow to actually pull more current and therefore end up brighter, but they're not. Oh well, it's not too bad. Let's check the current draw actually. Should be good enough of a measurement. Yeah, we got 39 milliamps, so that's right up to the limit if we have it that way. And if we go with the blue and green, we have 29 milliamps. So blue and green does pull a little bit less current than red and yellow. So that's pretty much what I had expected. That works just fine. So once I get the insulation, I wonder what the dielectric strength of hot glue is. But anyhow, once that gets done, we'll pretty much be good to write code and see what I can make this thing do. Alright, so I'm going to start off on the code here to give you some idea of how this is going to work, and then I'm just going to go ham on it, I guess, and see how many different animations I can get this thing to do. So let's go ahead and open a new one here, and we're just going to start off. I did a little bit of testing with it, and I've determined that the red-yellow combination is pin number 0 when that's high, and therefore that makes the green-blue, or it'd be blue-green in the order that it's on there. So blue-green combination is going to be pin 1, and then underneath all of this we're going to make statements, essentially. So we're going to have void, we'll just make it RY, and that is going to be, alright, so void RY is going to be digital write red, yellow, that's going to be high, and then digital write, oops, digital write green, sorry, it's blue-green. Blue-green, that one's going to be low. And then I'm going to make another function that's going to be, instead of red-yellow, we're going to do blue-green. and then we're gonna go and just flip these. So that'll be low. This one will be high. So and then in the void setup, we're just gonna set pin mode. Apparently I can't type tonight. So red, yellow is going to be output, and then pin mode. Blue, green, also an output. And also down here, I'm going to put another one of these. It'll just be off, and then that'll be low and low. And that should verify, hopefully. Alright, so that appears to be compiling. No, I don't have it set right. This will be ATtiny 85 at 1 megahertz, and I don't have the... Alright, so that varies or verifies just fine. So that's using 4% of program storage space and 9% of RAM. So we have plenty there to fill up. And the first thing I'm going to do is just, we should be able to call RY, put a delay. Oh yeah, let's go 1 second. And then we'll go off. And then we'll call GB or BG. Alright, so this little bit of code here should work to call these functions and actually work properly and kind of get something that blinks at least. So I'm going to test that real quick, then I'm going to write some more code. So I've got to dig out my old programmer for the ATtinys too. Alright, so here we are. This is the just initial bit of test code. So it does exactly what I figured it would do. So this is what the initial bit of test code does. As I said, it just kind of alternates between the two colors. So proof of concept seems to be working great. Now we just got to make some more patterns with it. So that should be fun. All right, so I got the lights turned mostly off in this room, and we're going to go ahead and show you what I've gotten it to do. This may not be completely final yet, but it goes through a few different patterns, and I'll let you see there. And you see I do get all 4 colors turned on at once. Camera's actually doing okay with the colors, it looks like right now. Usually it washes them out a lot more than that. We have 16 LEDs on this thing in total, so individually they're not amazingly bright. They're reasonable enough. I mean, you can definitely see them, and it's in a dark room, it's definitely not a problem. But you see we got some fading effects, and they'll even fade back and forth between the two colors here in a second. It doesn't do an amazing amount of effects, and it'd be great to have like a mode switch or something like that on here, so you could actually set the effects, and I might work it or figure out how to do that here in the next couple of days. But really the last thing that this needs for sure is just a case for this little board here, which that'll be easy enough to 3D print and just stick it in there. So that won't take too much. But this is where the state of the project is now, and I'll see you when we move on to the next step. Alright, so I've got this project finished up here pretty much. I mean, I might still modify the code a little bit, which I'll put the code down in a comment, by the way. So a little box here, I printed it in red because we've got red box, white cable. You know, seems to make sense for Christmas colors. We've got the red wire as well. Maybe I should have used green for the box, I don't know. Anyway, printed fairly nicely. I didn't even have to use any glue on this. It just slides right in. And then inside we've got the circuit board, as I showed before. really simple. We've just got a decoupling cap for the microcontroller just in case. It probably doesn't actually need that, but it's there. Then we got the 2 resistors for the LEDs, and that's it. Just all wired on the back. It did occur to me after I did this that I probably should have put some little standoffs or something down in the bottom of this case in order to hold the board up off the bottom, but it doesn't really matter. It just goes down there. Then this piece goes on the ears. This just slides down. That right there is a cutout for the capacitor. And then these two just go into the slots there that are cut out for the wires. So that just slides right on like that. And I might glue that down anyway, but I'm not sure I'm really done programming that yet. So anyway, I hope everyone had a happy Thanksgiving, and I'll see you next time, guys. Bye.